In this demo, we are going to present our system Centaur. Centaur tries to schedule the links in a wireless LAN so as to minimize the interference experienced by the links. In this particular example, you are able to see two windows. Each of them correspond to two different clients. The top window corresponds to client 1, which is going to show us the amount of good put experienced by client 1 in real time, and the bottom window will show us the amount of good put experienced by client 2. We are now going to start iPerf from the access point connected to client 1 and see the amount of throughput it gets in the absence of client 2. We have now started the link, and as you can see, client 1 is now experiencing a throughput of about 5 Mbps. The physical layer data rate of the link is actually set to 6 Mbps, therefore it's almost getting full throughput at this point. That is, this is a good quality link and it's not experiencing interference from any other source right now. We will now switch on client 2, which is connected to a different access point, but this access point happens to be a hidden terminal to this particular client 1. So what we will see is an example of a one-way hidden terminal. So client 1's throughput should probably go down and client 2 should not be affected as much. So at this point we are going to start client 2. We are going to run iPerf from its own access point to client 2 and look at the throughput. So as we can see, client 1's throughput has gone down quite a bit. It's experiencing an average throughput of 0.5 Mbps, whereas client 2 has taken up the entire wireless bandwidth. It's almost experiencing a throughput of 5 Mbps at this point. And this is an example of the classic one-way hidden terminal where one client is suffering from hidden interference whereas the other client is not. This is basically because the access point connected to client 2 is not able to carrier sense the access point connected to client 1, and therefore it causes losses. We will now switch off the interferer, that is, we'll switch off the access point connected to client 2, and we will see that the amount of throughput experienced by client 1 at this point should go up once again. So now that client 2 is switched off, client 1 is experiencing full throughput close to 5 Mbps. So at this point what we will do is turn on Centaur, which should schedule packets belonging to both the clients and therefore reduce the amount of interference. As we are able to see, client 2 is now switched on and it's not really interfering with client 1 at this point of time. In fact, client 1 and client 2 are indeed sharing the wireless channel and therefore each getting around 2.5 Mbps, which is a fair share, which Centaur essentially is able to give these two clients their fair share because it tries to schedule the links and minimize the amount of hidden interference in the network.